All right, welcome to Unit 8. So we're going to start Unit 8 off with 8.1, angles and degrees. Unit 8 is an intro into trigonometry. So what we're going to do in 8.1 is we're going to sketch angles on a coordinate plane. So you know how to do angles and stuff from geometry, but now we're going to do it on a coordinate plane. Then we're going to determine angle measures that are on the coordinate plane. Then we're going to look at what coterminal angles are and identify them. And then we're going to convert decimal degrees and degrees, minutes, and seconds, also known as DMS, from one to the other. Okay, so 4 objectives for today's lesson. So first off, some angle terminology. An angle, as you know, is 2 rays connected at a same endpoint, and that endpoint is called the vertex. So this point right here is the vertex. That's not new to you. And we use the symbol theta to represent degrees. Either you're going to be given a degree or we're going to use the symbol theta. It's not going to really show up in this lesson, but it is going to show up later on in Unit 8 and further along in pre-calc. So just know that that's Greek symbol theta means degree. Standard position of an angle means the initial side is on the x-axis, okay? And it's on the positive side of the x-axis. So when the initial side is located on the positive part of the x-axis, that means this angle is in standard position. Wherever the angle ends is that terminal side, okay? So a terminal side is where the angle ends. So we could have a terminal side here, we could have a terminal side here, we could have a terminal side here, we can even have a terminal side on the axes, okay? So just know that the terminal side is in conjunction with the initial side to create the angle on the coordinate plane. And standard position is when the initial side is on the positive part of the x-axis. All right, and then we also have quadrants, which is like way back in your elementary or middle school days. Quadrants 1 through 4, so it starts in the top right and it works its way counterclockwise on what 1 through 4 are. Okay, so quadrants are from 1, 2, 3, and 4, and we use Roman numeral notation for that. Okay, so just a little terminology to help you guys out here as we move forward. So what we're going to do now is we're going to draw some angles, and we're going to use line features to do that. In GoFormative, you will have line features to draw. So main thing we need to understand about the coordinate plane is that this x-axis starts at 0 degrees, and it is also 360 degrees, okay? If you went full circle from the start of our initial position, our initial side, then that means if we went all the way around and finished back to where we started, that would be 360 degrees. So that x-axis serves 2 parts. It is 0 and it is 360. And every single revolution you do is 360 degrees. So that one revolution is 360. We can do a second revolution, that would just add another 360. We can do a third revolution, which would add another 360. So every revolution you do around this coordinate plane is 360 degrees. So we are asked to draw 315 degrees. If I were to go just 90 degrees, okay, a 90 degree angle, then we can tell that this part will always be 90. Another 90 degrees counterclockwise would mean 180 degrees. And another 90 degrees counterclockwise would be 270 degrees. So counterclockwise is considered the positive direction of degrees. I could also go in the negative direction, which would be clockwise. So if I were to start at 0 again, the 0 would actually be here, and the negative 360 would be here where it finishes. So it's the same point, same x-axis, but now we're going clockwise. Okay, we're going to go clockwise to get negative degrees. So this is actually negative 90 degrees when going counterclockwise. This is negative 180. That doesn't change, except it becomes a negative. And then we got negative 270 if we're going counterclockwise. All right, so using those facts, and that's every single coordinate plane, the 90, 180, 270, 360, whether it's clockwise or counterclockwise, positive or negative. Using this, we are going to get a line. So 315 degrees, that's a positive 315. So that means we're going to go in the positive direction. And that means we need to stop at 315. So that means we're going to go 90 degrees, 180 degrees, 270 degrees, And we need to go how much more to get to 315? Well, 315 is 45 degrees more than 270. So that means it would be exactly in the middle of 270 and 360. Okay, those 45 degrees is this middle of our quadrant basically. So we're going to go to about here. Okay, now I'm drawing that crescent that to show which direction we're going. Okay, you probably should draw that as well. Okay, and we're going to have a line that represents an angle. The terminal side is what we are drawing. So our terminal side, remember, it's right in the middle, and you're not going to be perfect. We're not using a protractor, but I want yours to actually make sense. If I know it's right in the middle of 270 and 360, then I'm going to the best of my abilities, put that angle measure between right in the middle. Okay, so this is my angle of 315 degrees. And I am going to actually, just because I'm going to actually put an arrow here, the initial side. So the angle, so notice that the blue arrow, the blue crescent that I drew, that is showing that we're going in this direction, and that's why it's 315 degrees, because we're going in counterclockwise direction, starting from the initial side, the standard position. All right, let's do negative 150. So negative 150 means we're going to go counterclockwise. So we are going to go this direction. Let's find out how far we're going to go in that direction. So if we go clockwise, we're going to go, here's 0. We got negative 90, and this would be negative 180. So that's too far. So we need to go 30 degrees less than 180. So that wouldn't, remember, in the middle is 45 degrees. So if I go 45 degrees from negative 180, that's going to give me negative 135. That's not, we want to go past that because it's negative 150. So it's going to be on the upper half of this quadrant. So something along this line right here. Okay, it's not in the middle because the middle again is 135, so it's got to be a little bit past it. So you got to use your best judgment, best of your abilities. As long as it makes sense, I'm okay with it. So now we have to draw our line to represent our angle. And I should have an initial starting point as well, initial side as well. So there's my initial side. Okay, so negative 150 degrees. Okay, negative 150 degrees. All right, how about 460 degrees? So it's positive, so we are gonna go in the positive direction. So we're going more than a full circle. So remember, if I, sorry, let me change colors to blue to keep it consistent, positive and negative. So if I went a full revolution, that's 360 degrees. I gotta keep going. I gotta keep going from there. So 360 plus 90 is 450. I got to go just a little bit further to get to 460. So I should be on the right-ish half of the quadrant, because if I went, remember, this is the halfway point. So halfway between 450 and 630 would be in the middle. So that's not where we're going. We're going just past 450. So 10 degrees past 450. So right about there is good enough for me if you went that far. So let's draw our line. There's our terminal side, and here is our initial side. So that degree right there would be about 460. So I would like you to draw the lines with the arrows, and I would also like to draw the directional pieces as well. These pieces right here. The curling to show how many revolutions around you went. Okay, because that's important, especially if you go past 360, that's super important. All right, so that's how we draw angles. What if we were asked to find angle measures? What if we were asked to do that? Okay, so this is very important because it does show the direction in which we went. Okay, so it doesn't tell you the direction it goes, so you have to kind of default to it's going in a positive direction. Okay, we're actually going to do two parts. We're going to do both positive and negative directions so we can know exactly how far, so just so we can identify either positive or negative. So let's do both of them just for the sake of this. So the positive means that we need to start from the initial side and work our way around to where it is. So this would be the positive direction. So count it off. From here to here is 90. from here to here is 180. And then if we keep going, we get to this point. Well, I need to know how far that is. So we can actually work our way backwards. If I went a full 360, I know that this part from here to here is 120. So we're going to take 360 and we're going to subtract that 120 that we're given. So we're going to be able to go 360 minus 120 to get the positive value. And that gives us 240 degrees. So it is a possible answer could be positive 240 degrees. Let's talk about the negative direction. If it asks us specifically for negative, then that's completely different. We got to go from the initial side clockwise to here. Well, there's nothing really to figure out here. We know that that distance is 120 degrees. The only difference is that's going in the negative direction. So this should be 120 negative. So negative 120 degrees. So both of those are answers for that angle. You will be asked questions like list all possible angles or list one positive and one negative. Now, technically, another positive answer could be 240 and another full revolution. So you could actually get you can get plenty of answers here. So for every 360 degrees, I can go ahead and add 360 to 240. That gives me 600. So 600 would be a possible answer. I could add another 360 and another 360 and another 360. So every single 240 degrees plus 360 over and over and over again comes out to the same angle. Okay, so every single you can add 360 over and over and over again, and that's the same angle measure. All right, we just did the regular 360 is all we really pretty much did. All right, let's look at number 5. Okay, I know that the distance between the x-axis in the negative part to the terminal side is 45 degrees. So let's work on the positive first. The positive initial side to here. So we're going 90 degrees. But let's work our way backwards. Let's say we went 180 degrees minus the given 45 degrees. Okay, so we're going to do 180 minus 45 to get our positive. And that gives us 135. So the positive degree measure would be 135. Let's look at the negative now. Let's look at the negative degree measure. So if I went clockwise, I would go 180 degrees plus another 45 degrees. So if I went negative 180 plus another negative 45, that's negative 225. All right, so a possible answer is 135 and a negative answer would be negative 225, okay? Remember, same thing. I could add 360 to 135. That would be 495. That's another possible answer for positive. I could minus 360 to negative 225 and get negative 585. That's another possible negative answer. So any adding 360 to positives or minusing 360 to negatives are also possible answers. All right, number 6, going in the positive direction. Starting from our initial side, we're going 90, 180, 270, and 30 more degrees. So 270 plus 30, that is 300 degrees. So that is one of our positives. Remember, we could also go plus 360 to get 660, but we're just going to go with the first ones for now. And in the negative direction, if I go all the way to here, that's negative 90, but now we're going to go backwards 30 degrees. So this would be negative 90. And since we're going counterclockwise, we'd be going plus 30. And that gives us negative 60 degrees. All right, so negative 60 degrees or 300 degrees. All right, so that's how we find angle measures. And it's going to ask you for stipulations like, is it good? I need a positive one bigger than 360, or I need a negative one, or select all possible angle measures for this angle. So just be prepared for any kind of angle measure that you're going to see. All right, moving on, coterminal angles. Okay, new terminology here for you. Coterminal angles are two angles that share the same terminal side, okay? So basically the positive and the negative version are coterminal because they share the same terminal angle. So going back to this slide right here, going back to this slide, That means 300 and negative 60, those, and number 6, those are coterminal angles because they share the same coterminal side, or they share the same terminal side, okay? So it is very, very possible to have two angles, one positive, one negative, or two positives, 300 and 660 are possible coterminal angles. They just have to share the same terminal side, okay? So let's take a look. So we have specifics here for number 7. We need a coterminal side that is between 0 and 360. Well, if negative 130 degrees is the measure of, oops, sorry, went too far, back up. If negative 130 degrees is this distance, remember, because clockwise is negative, that means we need to figure out what the coterminal angle is going this way, all right? And it's really simple to do that. You can count it out if you want to, or you can just straight up add 360 degrees to it. And that comes out to 230. So this coterminal angle is 230 degrees. Again, you can add 360 to that, and that could be 590. You could have that as a coterminal degree. You can also minus 360 and get negative 490 as a coterminal degree or a coterminal angle. But remember our specifics. We needed one between 0 and 360. 230 does fall between that, so that is our answer. We have to have it meet the criteria. All right, number 8 is asking for a positive and a negative coterminal angle to 130. So that's a positive 130, so it went this direction. So in order to get another positive coterminal angle, we just got to do the same thing, but 360 plus that. So we got to go like that. So again, we can add 360 to this angle, and that gives us 490. So that would be our positive coterminal degree. To get our negative, what do you think we would do here? If we're going to go in the opposite direction, clockwise, you can count it out again, or you could minus 360 from 130. Okay, so we had the 130. Now we can minus the 360. That's another way you could do it. That gives us negative 230. Okay, so 490 is our positive, and negative 230 is our negative. All right, now we have the all coterminal. It wants us to write one single expression that represents every single coterminal angle. So we're actually going to write a linear expression here. Okay, so it's actually pretty simple. All you got to do is take the measure of the angle that you're given, so 30. So I'm going to take 30. And remember, every single coterminal angle to this would just be adding 360 to it. But we want to be able to say we can add 360 however many revolutions we want. So that would just be n revolutions, the number of revolutions. So this is the expression that represents all coterminal angles to 30 degrees. So whatever the angle measure is, that goes first, and then you just hit plus 360 degrees n. And that is your answer for all coterminal. So you will have questions that ask for all coterminal. That's how you write it. All right, whatever the angle is, plus 360 n. Okay, and don't forget the degrees for your labels. All of these, you got to make sure you put degrees for your labels, and GoFormative has a button for that. All right, cool. So that is objective number 3. Let's keep moving along here. All right, last part. Okay, we're going to do it twofold. We're going to go degrees, minutes, and seconds to decimal degree, and then we're going to go decimal degree to degrees, minutes, and seconds. Okay, so degrees, minutes, and seconds are another way of measuring degrees. It's the Babylonian way of measuring it. It's a base 60, just like time, so 60 minutes and 60 seconds. So it's all counting base 60. And we use this for like stuff like latitude and longitude on the Earth, for coordinates and stuff. So it's just another way of writing a degree. So what I'm giving you right now is DMS, degrees, minutes, and seconds. That's the version I'm giving you. And I'm asking you to rewrite them into decimal form. So what is the decimal form of this? So here is how you convert. All right, we are going to take the 48 degrees, and we're just going to say 48 degrees plus, we take the minutes, okay, 1 dash, 1 apostrophe means minutes, and then 2 apostrophes means seconds. So this one, so number 10 does not have seconds, it just has minutes. Because it's base 60, we're going to do 30 minutes divided by 60 minutes. All right, and that's going to be our decimal, basically. So we're going to do 48 degrees, and in class calc, you can go ahead and type 30 divided by 60, or in your head if you see it. So, and we get 0.5. So we just add those two together. So our degree in decimal form, oh, sorry, I did the degree sign too early, is 48.5 degrees. So all I did was take the degrees and I left it as the whole number in the front. And then for the decimal part, I take the minutes and put it over 60 and figure out what that decimal is. And that's our answer, 48.5 degrees. All right, let's try it with number 11. We've got degrees, minutes, and seconds. So how does that convert? So let's look at it here. 22 degrees goes in the front. Then we're going to convert 45 minutes over 60. That's the conversion. And then we're going to add the seconds. Here's how you do the second conversion. Take 10 seconds and you divide it over how many seconds are in an hour. There are 60 times 60 seconds in an hour, because 60 seconds for every 60 minutes in an hour makes it 3,600 seconds in an hour. All right, so that's the conversion. So in class calc, you can type it out exactly the way this looks. So I'm actually gonna go into class calc and we're gonna type it out. So we're gonna type in class calc 22 plus 45 over 60 plus 10 over 3,600. And it gives us that decimal. We're gonna go to 4 decimal places. So 22.7528 is where we are gonna go. So that's what I'm gonna write for my answer. So 22.7528 degrees. So converted to decimal form. All right, number 12, same thing. Take the 88 degrees, keep it degrees. We're gonna add it to 26 minutes over 60 minutes in an hour. And we're gonna add that to 42 seconds over 3,600 seconds in an hour. And that's what we're gonna type into class calc. So we type all of that into class calc and we don't get 4 decimals, so that's okay. So we're gonna just write the whole answer. 88.445 degrees is the decimal form of that DMS degree. All right, so that is converting DMS to decimal. DMS to decimal, that's the process for doing that. For the other way around, it's just a little bit different. So let's look at our very last slide here, short lesson today. We are gonna convert decimals to DMS, okay? So here's how that's gonna work. We are gonna take 45.5 and we are going to write it out like this. You're gonna take, excuse me, you're gonna take the 45, that's gonna stay in the front, that's the degree, that's the whole number. Then we're gonna take the decimal, 0.5, and we're gonna multiply that by the number of minutes, 60 minutes. And that's gonna convert it to minutes. There's no other, so that's the first part we're gonna do. So 0.5 times 60 comes out to 30 minutes. That is a nice clean whole number. That means we are not gonna have any seconds in our DMS because the minutes came out to a nice clean whole number. If it was a decimal, I would keep going, and I'm gonna show you that in number 11. But for now, all I have is 45 degrees and 30 minutes. So that is the DMS version of 45.5. So make sure you put that apostrophe where it belongs. Let me make it a little bit clearer that it's an apostrophe and not an exponent of 1. Okay, so use the apostrophe to represent minutes and use a double apostrophe to make it count as seconds. All right, so what happens when we actually don't get a nice clean number for minutes? Well, let's look. We got 12 degrees in the front, and then we're gonna have 0.45 degrees times 60 minutes to figure out what the minutes would be. All right, well, if I do 0.45 times 60, I actually do get another nice clean number. Sorry, spoiler alert. Gets another nice clean number of 27 minutes. Okay, so we don't have seconds again in this one because it came out to a nice clean whole number. So our answer is 12 degrees and 27 minutes. All right, now I promise this one will have seconds. Okay, so let's do it out. Now the negative sign, don't put the negative sign until the very end because it's going to get confusing with the adding and the subtracting and all that stuff. So just know that your final answer is going to come out negative. So I'm just going to put a negative sign here and a negative sign here and a negative sign here. Okay, so just so I know it's negative. So I'm going to take the 142 degrees, put it in front. I'm going to take my decimal 0.125 and I'm going to times that by 60 minutes. And when I punch that into class calc, the decimal I get is, where is it? Oh, I got to do it in class calc, sorry. So 0.125 times 60. I get 7.5, not a nice clean number. So I'm going to convert this to 7.5 minutes. Now that is not our final minute because it didn't come out to a nice clean number. So here's how it's going to go from here. We still have 142 degrees. We still have 7 minutes, but now I'm going to take that decimal, that 0.5 decimal from the minutes, and we're going to convert it to seconds. Now I'm not going to times it by 3,600 like we did for division because this is the seconds column. We're still going to keep that 60. Okay, we're still going to keep the 60 to represent the seconds. So I got to take 0.5 of 60 seconds. All right, I don't need class calc anymore, so I can get out of here, go back to our presentation. And we have 142 degrees. We have 7 minutes, and we have 30 seconds. So I'm going to write all these together. Do not forget we had a negative sign. So I'm not doing negative 142 plus 7 plus 30. I know it looks like that, but I'm just combining my degrees with my minutes with my seconds. And that is my DMS version of the decimal degree in number 12, okay? You may get a decimal when you do the seconds. If you were to get a decimal for the seconds, you do not keep going, you just write the decimal. So for example, if I were to do like, something like 0.83 times 60. All right, 0.83 times 60 gives me 49.8. So what that would mean I would do is if I got 49.8, then that means I would not convert it anymore. I would just leave it in terms of seconds. So let's say it was 28 degrees, 5 minutes, and then I would just write 49.8 seconds. Okay, so if you get a decimal for seconds, you just write the decimal out. It is possible to have that. Okay, but for number 12, we didn't get a decimal. We got a nice clean number, so that's a good thing. So that is how you convert decimal degree to degrees, minutes, and seconds. Okay, that is all of 8.1, short lesson today. So make sure you guys do the assignment for 8.1 and reach out if you got any questions. Have a good one.